Distance and displacement. The distance travelled by an object is the actual length of the path covered by a moving object, irrespective of the direction in which it travels. When an object moves from one position to another, the shortest straight line distance between the initial position and final position of the object, along with direction, is known as its displacement. From this, we may conclude that 1. Distance is a scalar quantity because it has magnitude only and has no specified direction. 2. Displacement is a vector quantity because it has magnitude as well as a direction. If we consider a child cycling for 400 meters and then 300 meters in two different directions, then 400 meters plus 300 meters is equal to 700 meters is the total distance travelled by the child, but the displacement of the child is 500 meters in northeast direction. It also shows that displacement cannot be greater than the total distance travelled. Uniform motion. An object has a uniform motion if it travels equal distances in equal intervals of time, no matter how small these time intervals may be. A car running at a constant speed of, say, 100 meters in 10 seconds will cover equal distances of 100 meters in every 10 seconds. So its motion will be uniform. The distance-time graph for uniform motion is a straight line. Non-uniform motion. An object has a non-uniform motion if it travels unequal distances in equal intervals of time. If someone drops a stone from the roof of a tall building, it covers unequal distances in equal intervals of time. It may cover 50 meters in the first 10 seconds, 90 meters from 10 to 20 seconds, 140 meters from 20 to 30 seconds, 200 meters from 30 to 40 seconds, and so on. The distance-time graph for non-uniform motion is a curved line. Acceleration. Acceleration of an object is defined as the rate of change of its velocity with time. When the velocity of an object is increasing, the object is said to be accelerating. Suppose a train starts off from the platform from its rest position and its velocity increases at a steady rate so that after 30 seconds, its velocity is 60 meters per second. Now in 30 seconds, the velocity has increased by 60 minus 0 equals to 60 meters per second. And in 1 second, the velocity increases by 60 divided by 30 is equal to 2 meters per second. The train is said to have an acceleration of 2 meters per second square. Retardation. The acceleration is of two types, positive acceleration and negative acceleration. If the velocity of an object increases, the acceleration is positive, and if the velocity of an object decreases, the acceleration is negative. An object is said to be retarded if its velocity is decreasing. Let us consider a train traveling at an initial velocity of 60 meters per second that encounters brakes and comes to rest in 5 seconds. Final velocity becomes 0. Now in 5 seconds, the velocity has decreased from 60 minus 0 is equal to 60 meters per second. The velocity decreases by 60 divided by 5 is equal to 12 meters per second. The train is said to have a deceleration of 12 meters per second square. Average velocity. If the velocity of an object is always changing but changing at a uniform rate, the acceleration is uniform, then the average velocity is given by the arithmetic mean of the initial velocity and final velocity of a given period of time, that is, average velocity is equal to initial velocity plus final velocity divided by 2, or V bar is equal to u plus v divided by 2, where v bar written as v bar denotes the average velocity, u is the initial velocity and v is the final velocity.